Good morning students. This session is for class 11th. Students, in last sessions we have completed the topic like force, Newton's laws of motion and friction. So students, this session can become very easy for you if you revise that topic, because that topics will help you to understand the concept of work, power and energy here in this chapter. Okay, so let us start with the concept of work. Okay, and I want to advise that please revise the previous session, because that will be very beneficial for you to understand this concept. Okay, so let us start. You can see first topic is work. Okay, so what is work? In physics, work stands for the mechanical work. So in this session we are talking about the mechanical work. Okay, and the in physics the work is defined something different, like in this word is used in social terms. Okay, so let's see what is difference between these terms which is used in physics and in our daily life. Okay, so you can see here work is said to be done by a force when the body is displaced actually through some distance in the direction of applied force. So you can see here this is the definition of work. So it is says that the work has to be done if body is displaced in the direction of force. So suppose this one is a body and we applied some force in this direction, and if this body is displaced from this position to some other position, then work has done in this case. Okay, so this is the definition of work. Now let us understand this concept in detail. So you can see, however, when there is no displacement in the direction of the applied force, no work is said to be done. So if there is no displacement, it means work is zero in this case. Okay, that means work done is zero. If displacement is zero, it means work done is zero. When displacement of body in the direction of force is zero. So from this discussion you get a point. If a force is applied on a body and body displaced from its initial position to some other position that may be considered as the final position of the body, so in that case it is said that the work has done. But if there is no displacement in the position of body after applying the force, it means we can say that the work is zero in this process. Okay, so if there is no displacement, there is no work. So let us discuss the mathematical concept of work. So you can see in this picture, this one is an object and force is applied on this object at an angle theta with the horizontal. You can see this angle is theta. Okay, so what happened in this case? Let's see. Suppose a constant force F acting on a body produces a displacement S in the body along the positive x direction in the figure. So you can see force is applied in direction theta from the horizontal axis, but there is displacement S along the x axis. Okay, so if theta is the angle which F makes with the positive x direction of displacement, then component of F in direction of displacement is F cos theta. So since you know that this is the force, this force is a vector quantity, so you can get a component F cos theta along x axis. This one is the component, and another component that is F sin theta. So you can get this one F sin theta. So this one is F sin theta. So you can see F sin theta is exactly opposite to the weight. Okay, and F cos theta is in the same direction of the displacement. So as work done by the force is the product of component of force in the direction of displacement and the magnitude of the displacement, So you can see here work is equal to F cos theta into S. Okay, so the final answer is W is equal to F cos theta into S, or you can say Fs cos theta. So you can find the value of maximum and minimum work from this relation. So from equation number 1 you can get the value of maximum and minimum work. Okay, so let's see. If displacement is in the direction of applied force, then theta is equal to 0. In this case you will get from equation number 1 F cos 0 into S, so that is Fs. Okay, now equation 1 can be rewritten as W is equal to F dot S, and that is W is equal to F dot S, because after using the definition of scalar product you will get F S cos theta, Fs cos theta. So this same equation 1 can be written in scalar product form, that is W is equal to F dot S. Thus work done by the force is the dot product of force and displacement. So you can see here the work done by the force is the dot product of force and displacement. In terms of rectangular component, F and S may written as F is equal to, if we take the component of force like Fx, Fy and Fz along x, y and z axis, so you can write F is equal to Ifx plus Jfy plus Kfz, and the component of S is given by Ix plus Jy plus Kz. You can write these components like this. So from equation number 2, that is this one is the equation number 2, you can find out the value of W by using the dot product. So you can use the concept of dot product here and you will get the final answer for work. So let's see. So you can see here W is equal to, this is the value of F and this value of displacement. So after dot product you will get, since you know that I dot I will be 1, so the result is of the first dot product is Fx into x, you can see here, and the I dot j is 0, so this component is taken as 0, and then I dot k is also 0, so Fx and product of this Ifx and Kz is also 0. So only those part is given here which contains the similar unit vectors like I dot I, j dot j and k dot k becomes 1, so their coefficient are present here. You can see here in right hand side there is no vector quantity, it means the result is scalar. So this W is a scalar quantity and you can find out the value of W by using this definition of dot product. Okay, so obviously work is a scalar quantity, that is it has magnitude only and no direction. However, work done by a force can be positive or negative or 0. So you can find out this value by using the value of cos theta. If cos theta is 0 then it is maximum, if theta is 90 degree then cos theta is 0 and the work is 0, and if theta is 180 degree then you will get cos 180 is equal to -1, so in that case you will get negative work. Okay, now we are going to study dimension and unit of work. So let's see dimensions and units of work. So since work is defined like this, force into distance, so we can use the dimension of force and distance and you will get the final dimension of the work. So for force it is m to the power 1, L to the power 1 and T to the power -2. This is the dimensional formula for force, and for distance it is L. So the final dimensional formula for work is m to the power 1, L to the power 2, T to the power -2. So this is the dimensional formula for work. The unit of work are the two types. First one is absolute unit and second one is gravitational unit. So let us understand the concept of absolute unit and gravitational unit. So you can see on the screen absolute unit. The first one is joule. So it is the absolute unit of work in MKS system, or you can see on SI. Work done is said to be 1 joule when a force of 1 Newton actually moves a body through a distance of 1 meter in the direction of applied force. तो यहाँ पे आप देख सकते हैं कि 1 जूल को हम लोग कैसे डिफाइन कर सकते हैं. तो इस इक्वेशन में जो एफ डब्ल्यू इज इक्वल टू एफ इंटू एस होता है, डब्ल्यू इज इक्वल टू एफ इंटू एस, ये हमारा फार्मूला है. इस फार्मूले की में से डब्ल्यू की वैल्यू 1 जूल आ जाए, इसके लिए हमें फोर्स को 1 न्यूटन और डिस्प्लेसमेंट को 1 मीटर करना होगा. तो इफ़ 1 न्यूटन फोर्स अप्लाई करने से ऑब्जेक्ट में 1 मीटर का डिस्प्लेसमेंट हो जाता है, तो उस केस में आप बोल सकते हैं कि वर्क डन 1 जूल हुआ है. तो उसी चीज़ को यहाँ पे आपको स्टेटमेंट दिया गया है. यू कैन सी हियर when a force of 1 Newton actually moves a body through distance of 1 meter in the direction of applied force, then the work done is 1 joule. Okay, joule is also can be replaced by the unit Newton meter. Okay, so 1 Newton meter is taken as 1 joule. Now second one is erg. This one is the CGS unit. Okay, CGS unit of work. So you can see here it is absolute unit of work in CGS system. Work done is said to be 1 erg when a force of 1 dyne, because you know that dyne is CGS unit of force. So 1 dyne actually moves a body through distance of 1 centimeter. So since the unit of length is centimeter in CGS system, so if you take force and length in CGS, you will get finally the unit of work in CGS system. So from the same relation you will get here 1 erg is equal to 1 dyne into 1 centimeter. So this one is the definition of erg. So these two are known as the absolute unit of work, that is joule and erg. First one is in MKS system and second one is in CGS system. Okay, let us consider about second one, that is known as gravitational unit. So you can see here the kilogram meter. It is the gravitational unit of work in SI. Work done is said to be 1 kg meter when a force of 1 kg force move a body through a distance of 1 meter in the direction of applied force. तो यहाँ पे आप देख सकते हैं if 1 kg force move a body through 1 meter, then this work is known as 1 kg force. So from the relation W is equal to Fs cos theta, you will get 1 kg meter is equal to 1 kg force into 1 meter in the direction of force. So theta is taken as 0. So finally you will get 9.8 joule. So you can see here 1 kg meter is equal to 9.8 joule. This is very important relation. And second one is gram centimeter. So similarly you can see here it is gravitational unit of work in CGS system. So work done is said to be 1 gram centimeter when a force of 1 kg force, when a force of 1 gram force moves a body through distance of 1 centimeter in the direction of the applied force. Now from W is equal to Fs cos theta, you can see 1 gram centimeter is equal to 1 gram force into 1 centimeter and cos 0 degree. So finally you will get 1 gram centimeter is equal to 980 dyne into 1 centimeter into 1, because cos 0 is 1. So finally 1 gram meter is equal to 1 gram centimeter, it should be centimeter, 1 gram centimeter is equal to 980 erg. So you can check the 1 kg meter and 1 gram meter. So 1 kg meter is equal to 9.8 joules and 1 gram centimeter is equal to 980 or so these are the different important relations in case of absolute and gravitational unit of work. Now we are going to study the nature of work done. So let's see about the nature. So although work done is scalar quantity, its value may be positive, negative or zero. So you can see work done is scalar quantity, but its value can be positive or negative or zero. So let's see when it is positive, when it is zero and when it is negative. So since we know the relation that is W is equal to F dot S, or you can write Fs cos theta, where theta is angle between the vector F and the vector S, that is displacement vector. So when theta is acute, that is if theta is less than 90 degree, cos theta is always positive and hence work done is positive. So if the angle between force and the displacement vector is acute angle in any case, then work done by the force is always positive value. Okay, so I hope you understand. When work done is positive, you can simply say if angle theta between force and displacement vector is less than 90 degree, it means it is acute angle. So in that cases the work done is taken as positive. Okay, for example, you can see here, when a body falls freely under the action of gravity, then theta is equal to 0 in that case, and cos theta becomes plus 1, and therefore work done by the gravity on the body falling freely is positive. Okay, so let me repeat this statement. You can imagine, or you have seen in many times, that when a body falls freely under the action of gravity, the direction between the displacement and the force are same. It means you can say the angle between force and the displacement is 0 degree. In that case, cos 0 is equal to plus 1, and so we can say that the work done by the gravitational force is positive. Now let us consider about the concept of negative work. So you can see the formula, that is W is equal to F dot S, or you can also write F S cos theta. When theta is obtuse, it means if theta is greater than 90 degree, cos theta is always negative, and hence work done is negative. So student, you can say if angle between force and the displacement vector is greater than 90 degree, in that cases the work done is negative. Okay, so you can, if you know the value of angle theta, you can find out the work, nature of work. You can say either it is positive or negative or zero. So you can see here, when theta is obtuse means if it is greater than 90 degree, cos theta gives negative value, and hence work done is negative. So if you want to find out the negative work, or negative work has to be done in the case where the angle between the force and the displacement vector is greater than 90 degree. Let's see with an example. So for example, you can see here, when a body is thrown up, its motion is opposed by gravity. The angle theta between gravitational force and the displacement vector S is 180 degree. So as cos theta, that is cos 180, is equal to minus 1. Therefore work done by gravity on a body moving upward is negative. So you can see here, if body is moving upward, the force that is gravitational force is opposite to direction of displacement of the body. In that case, the theta between the displacement vector and the gravitational attraction is 180 degree, and work done by gravitational force on that body is negative. Okay, now when it starts falling downward after some time, in that case the angle between gravitational attraction, that is gravitational force, and displacement becomes 0 degree, and in that case the angle between force and displacement vector is 0, and the work done by gravitational force is positive. So if body is moving upward under the effect of gravity, then work done by the gravitational force is negative, and when it falls freely under the effect of gravity, the angle between force and displacement is zero and the work done become positive. Okay. Now we are ready to understand the concept of zero work. So let's see. When force F or displacement S or both are zero, so it can be zero. It means there is one case in which either force or displacement or both are zero. In that case, you can say work is zero. But there is another condition, that is when angle between F and S is theta is 90 degree. It means if angle between F and S is 90 degree, then cos 90 is zero and therefore work done is zero. It means in any condition where force and displacement are perpendicular to each other, then in that case it is considered that the work done by the force is zero. Okay, so let's see with the help of an example. When we push hard against a wall, the force we exert on the wall do not work because displacement in that case is zero. However, in this process our muscles are contracting and relaxing alternately, and internal energy is being used up. That is why we do get tired. So if you try to push a very heavy wall, you feel that there is no displacement in the position of wall, but you feel tired many times. So the reason behind this is when you try to push a wall, due to very high inertia of the wall, it is not ready to move, so displacement in that case is zero, and as displacement is zero, work done in this process is zero. Now there is another question: if work done is zero, then why we feel tired? Okay, so because our muscles are contracting and relaxing alternately in this process, so our internal energy is being used up in this process, and that's why we are, or you can say that's why we do get tired. Okay, so there is no work done in this process, but we can tired in that cases. So these are very interesting questions, and this is very important concept of the zero work. So I hope you understand what is meaning of zero work. Next topic is work done by variable force. So students, first let us consider what is meaning of variable force. So if the value, or you can say the magnitude or direction or both of a force is continuously changing, then that type of force are known as variable force. Let me repeat the concept of variable force. If magnitude or direction or both of a force is continuously changing, so that type of forces are known as variable force. But our aim is to find out the work done by variable force. Okay, so let's see the graphical method by which we can calculate the work done by these type of forces. So let us see. A constant force is rare. It is the variable force which is encountered more commonly. We can therefore learn to calculate work done by the variable force. Let us consider a force acting along fixed direction of x-axis but having a variable magnitude. We have to calculate work done in moving the body from A to B under the action of this variable force. To do this, we assume that the entire displacement from A to B is made up of a large number of infinitesimal displacement. One such displacement shown in figure from P to Q. So you can see as the displacement PQ is equal to dx is infinitely small. We consider that all along this displacement force is constant in magnitude and is equal to PS as well in same direction. Okay, so we are considering these things to complete our requirement or RM. So let's see here. Let's see the diagram first. it will help you to understand the concept. So you can see this is the force, this is the displacement, and this one is force. You can see with increase in displacement, the value of force along x-axis is continuously increasing between point D and C. So to understand this concept, let us divide this curve between point D and C into infinite number of points. Okay, now any two points are taken as P and Q. This one is P and this one is Q, and we are considering here that the distance between these point P and Q is very small, or you can say infinitely small, or you can say as small as you can imagine. So in this part we can consider that the force between P and Q is at least constant. It is not constant between point C and D, but it is constant between point P and Q, because point P and Q are very close to each other. You can say the point Q is just next point of the P. So we can only imagine these things. Okay, so in this interval, that is PQ, we can take the force as a constant force. So for a small amount of work done in moving the body from P to Q, the force is small force is constant force is taken as F, and the displacement between point P and Q is taken as dx. So you can see here PS into PQ. Okay, so area of this strip, that is PQRS. You can see this PQ is the distance between these 2 points, and we are considering that F is force, that is constant force between these 2 points. So the total work done is moving the body from A to B is given by W is equal to sum of dWs. Okay, or you can say W is equal to sum of product F into dx. If the displacement are allowed to approach 0, then the number of terms in the sum increases without limit, and the sum approaches a definite value equal to area under the curve CD. So you can see here, if you are taking this PQ is very close to each other, this shows that the number of terms in sum increases. This number of terms in sum increases. If these strips are very close to each other, we must add more number of strips together to get the total work. Okay, so you can now use the integration formula to find out the value of work done, and you can replace this summation by integration. So you can see this is the curve, this one is the variable force. So hence we can rewrite W is equal to limit dx tends to 0, this one is f dx. So in the language of integral calculus, we may written as W is equal to from x a to b f dx, where x is equal to 0, or you can say initial point, and this one is the final point. Now you can write W is equal to from xa to xb area of the strip PQRS. You can see this one is the area of strip PQRS. Now total area under the curve between f and x is from x is equal to xa to x is equal to xb, that is area ABCDA. Hence work done by a variable force is numerically equal to the area under the force curve and displacement axis. So this one is very important. Okay, so area on F and dx curve will give you the amount of work done by the force. Mathematical treatment, you can see here the mathematical treatment of this similar concept. So students, in next session we will discuss the mathematical treatment of this concept. Okay, so try to revise this topic and try to derive the formula for work done by variable force. Okay, thank you for watching this session. We will try to solve some questions based on this topic in next session. Thank you for watching. Thank you very much.